Welcome back to a new video for the networking series. Thank you if you watched the last video where we went over routing concepts and protocols. That was a pretty lengthy one. But nonetheless, this one, we're going to go over troubleshooting common network issues. Now, some of the most common networking issues, right, think of usually there's particular devices, connectivity, network connectivity, right? Device configuration. What we're going to focus on is reviewing different parts of device configuration, viewing the routing tables of different devices, interface status, identifying and resolving correct gateway. Because I mean, that's what IT is mostly all about, no matter what sector you're a part of, is solving an issue and creating the most efficient way to solve an issue and sometimes being a bit creative with it. But nonetheless, we're going to dive into the common, again, troubleshooting common networking issue. Let's go ahead and get started with the first exercise. So for our first exercise, we're going to go over considerations for troubleshooting networking devices, right? So after you normally identify the issue on the network, you start to, go through various steps in troubleshooting the process, right? And you typically check the device configuration and identify if anything has changed. You also need to check like your interface status or your VLAN assignment or similar configuration. What we're about to do is actually make sure this is good. Get familiar with some basic considerations that someone or like myself would need to perform while troubleshooting. So what I'm going to do first is take a look at some review different parts of the device configuration because every network consists of different devices naturally, right? And and it's common to have several network or system admins that can access those devices and configure them, right? And one of the steps of troubleshooting a particular issue is to verify the device configuration and check a particular configuration you think might be related to the problem. Now, what we're going to do is actually head to a site in just a moment. Um, we're going to access the pfSense firewall here, which I've done in a prior video before. I want to make sure that's secure. Okay, connection is private. Um, All right, now as I mentioned in my other video, what pfSense is, it's an open source firewall that you can install on many different virtualization platforms that configure it with different features like network address translation, port forwarding, DHCP, DNS, open VPN for site-to-site remote access, things of that nature, right? And then you can use these different tabs to review the firewall configuration. But nonetheless, we're going to go to take a look at our diagnostics here. So let's see. Take a look here. I'm just looking at the drop-down menu, looking at all the options related to the system itself, like the certificate manager, the general setup, the packet manager used for upgrading, and installing in different packages like routing and user setup. I'm just going to go to general. All right, and on this page, I can find basic firewall information like the host name, domain name, DNS server setting. But I'm going to take a look at all the configurations options available. Let's see. There's quite a few. Not too bad. So let's take a look at, let's see, take a look at route gateways, right? Now I can view configure gateway static routes and gateway group, which is normally used for load balancing and things of that nature, right? So now I'm just going to take a look at our wide area network, right? And here you can, I can verify the interface configuration of the wide area network, right? And there's these different things. I believe I've done this on another video. You can also view the interface configuration of the local area network as well, right? And under firewall, I can this configuration, right? I can find all the configuration related to NAT firewall rules and port forwarding. Actually, let's take a look at the rules here. Now here, I can look at all the rules applied to configured interfaces, and this is an important configuration option for troubleshooting issues related to, let's say, block services or between LAN and WAN zones, right? Well, let's take a look at here, and let's take a look at our dynamic host, right? Okay. So now on this page, the DHCP server is not enabled on the LAN interface. Just wanted to point that out. So let's take a look at VPN and open VPN. Now, VPN is used, as we know, for enabling virtual private networks or public network, and you can kind of find all the configurations related to site-to-site VPN and remote access VPN, right? So let's actually take a look here. There's nothing here. Okay. Nonetheless, we can move forward, right? So now we can actually view the routing tables of different devices. So a routing table provides information base that the layer 3 network devices use to determine the destination of the packets that arrive at a device. Now, when a packet arrives on the interface, the layer 3 device usually checks its routing table and based on the destination address, determine where it is to send the packet. So, routing table contains a list of routes to specific destinations, usually outgoing interfaces and metrics related to the route. So, so I'm actually going to take a look at here and take a look at right? Now we scroll down, we can see the IPv4 routes, right, that are currently present in the routing table. And we only have directly connected networks available in this routing table, it looks like. And every computer with an active network also has a routing table, and it's possible to add static routes as well. But enough of this. I'm going to minimize that and then open up the command prompt, of course, as the admin. All right. So let's actually do some route printing. All right, perfect. Now I can see these here. Not too bad. Now, another basic thing is that needs to be considered when troubleshooting network issues is to check the interface status. And the status of the interface can be up, down, or administratively down, or which can be, in other words, disabled. So now I'm going to view the interface status of different devices. So I'm going to restore this here, right? And let's go back up here. Take a look at the dashboard. Now we can take a look at the interface status, right, on here under the interfaces section here. And the up green arrow indicates an up status of the interface. Now the interface can also be checked from the status tab here. Let's see, through interfaces. And we can view a detailed report available on the configured interfaces. In addition to the interface status, I can also view other features related to the interface, such as like a MAC address, IP address, MTU, and the number of errors and collisions. And we also want to point out that I do not have any in or out errors and collisions on the interface, right? So actually I can close this out if it works. Actually gonna put this down here. We're gonna take a look at the control panel. That was task. All right, now here we'll find all configured network interfaces on this device, so we'll be able to view, different access types for connections. Right now, in some situations, if you're experiencing network issues, disabling and enabling the interface can solve the issue, which I've done on prior videos before. But let's take a look at the adapter settings, right? And if we right-click Ethernet 2, and we click disable. Right. Probably shouldn't have done that. Well, you know what? That's fine because this is the primary, this is secondary. So, but nonetheless, Ethernet 2, as you can see now, is disabled. So I'm going to actually enable it again. Right. And now it has an enabled status. So you can also get into, not too much in this video, but the VLAN assignment, which stands for, again, virtual local area network. We all know this, and it represents the logical network segmentation of the OSI layer 2. And every managed switch has the capability to create multiple different VLANs and to configure its ports as access or trunk ports, right? Which I went over in a prior video also. And also network performance baselines. Every modern network needs to have a monitoring tool that will enable you to monitor different aspects of your network, right? But nonetheless, we can now get into resolving common network connectivity issues. Now, I'm going to focus more on common network issues, how they arise and how they affect network performance. And I'll take a look into see how some incorrect gateway addresses and incorrect DNSs can cause problems related to host reachability and also in multiple gateway design, like special care or static routes. They have to be taken to prevent reachability issues naturally, right? So let's actually head back to control panel home, right? And let's go back here, right? And then let's actually click on here, right? And then let's see, access time. Okay, network connection detail. Okay, just looking it over as far as the different properties, right? So you know what? I'm actually gonna take a look here, and like I've done before, just take a look at the properties for the IP that it's using, right? And default gateway looks like it's 250. Let's actually let me change that. What happens? Close. Now I may lose connection to this device, unfortunately. But when I do this, but what I can do is access this server from another server to connect it, and then yep, there it is. That's fine. I'm actually going to connect to it here. MST. There it is. Perfect. So let's connect back to the other guy. Come on. Connect. All right, perfect. So I'm back in. I have an existing section for 110. Right, so I'm just going to click on properties here. Go back to IPv4. And I'm going to put 250 back in. All right, perfect. So now I'm just going to hit refresh here so it can do what it needs to do. Right. And actually, I'm going to close all these windows here. Right. I'm actually going to exit out of here. Let's stay connected to DC01. Now, sometimes there can be an incorrect IP address and subnet mask, as you saw. And incorrect IP addresses, subnet masks, usually cause when an IP address is assigned manually to a host, and an incorrect subnet can cause the host to have an incorrect subnet, of course. Now, what I want to do is identify, resolve an incorrect DNS issue. Now, DNS is very important for end users because issues such as inability to access a shared folder on a remote computer or browse to a website can arise when you have an incorrect DNS because the DNS resolves names to IP addresses because we don't have to remember all the IP addresses on the network of the internet, right? Because if also if you can't ping a host by its name and you can ping by its IP, then you're experiencing a DNS issue. So I'm actually gonna reconnect back to Win10. Use its command prompt if I can. Here. Let's take a look at our IP configuration. All right. Now I'm going to test to verify that the DNS is resolving names in the same domain. So I'm going to paint the domain controller, which is DMO1 by its name. Let's see. Okay, let's see. Okay. So good so far. How do you spell that? Okay. Now from the output, it could be seen that the DNS installed on the domain controller is resolving name to the IP address correctly. So I'm actually going to change the DNS address on Win10 just to check some few things. Okay. And of course, we want to look at our properties here. Okay. Now for the DNS, let's do the alternate. Actually, no. Let's do the preferred. Okay. Now, before I tested the DNS settings, I'm going to need to clear out the DNS cache first. So let's open up a new window. Yes, of course. So clear it out. Perfect. I successfully done it. So now I can try to ping the DMO1 server by its name. But not find the host. Right, it's because the DNS resolving is not working now, right? Because I used a non-existing DNS address, which is ends in 0.10 to show how incorrect DNS can cause issues. Now I'll need to, of course, enter the correct DNS for our Ethernet connection. So control panel, where are you? Mm. Mm. Change this back to 2. Everything seems to be on the up and up, and we should be good to go. Just to do that again, and now we're getting different results. Trust but verify, right? Now I'm going to take a look into identifying and resolving a missing route issue. Now, many organizations have complex, actually just close this out. Now, they have multiple gateways to different networks, and usually these routes are handled by static routes on a core switch device, and which can be misconfigured. Now, if we have a problem with connectivity to a specific host on the remote network, we can always check the routing. But traceroute is usually a good tool for this purpose. So what I'm going to try to do is access Web01, this server remotely from the current device that I'm on, Win10. And I might see that there's no route to the server. If I do see that there's no route, then I'm going to correct the issue. But first, let's actually ping first, see what's going on. Right, terminate route. Okay, so the ping does not work, but it doesn't mean that the remote desktop connection to the server is not working. So I'm actually going to see this here. Okay, let's see. So that's not going to work. It doesn't take this long to do that. Yeah. So that's fine. So we're going to use tracer, which I just mentioned. $30 hops. Now for the minus D lowercase d option, I put on a tracer command. I used it to disable resolving an address of the host name. So for the output, it would be seen, looks like there is no reply, and it could be because the ICMP protocol is not allowed on the gateway. So I'm actually going to stop this. Then I'm gonna out the print. Okay, now let's take a look here. So I only have a default route with 0.25 volt as the next hop IP. Now to access the server, I'm going to have to add a static route with pfSense as the next hop. So let's actually do that here. All right, perfect. So we've done that. I've added the static route that points to the server 1.10 and uses the pfSense, the IP address 0.1 as the next hop. So I'm actually gonna, let's see, minimize this, and then I wanna head back to. All right, so it looks like my connection is working now. Now I didn't have a route to the server, and I corrected the issue by adding a static route to the device. So I'm actually going to close this. So remote session, and now I'm going to check the trace route to the server as well. Let's see, it's on this one. Yes, it is. Let's check it. That was very quick. Trace complete, as you can see here. Everything looks pretty good, right? So now I'm just going to do some troubleshooting for network connectivity. So like problems related to network firewall and block services and how they manifest and how to pretty much troubleshoot them, like describing host-based and network-based firewalls and identifying block services, ports and addresses, things of that nature, right? Sometimes you may have low optical link budgets, certificate issues, hardware failure, host-based, network-based firewall settings, which is what I'm going to specifically get into. Now, in today's network security, security is one of the most important things, naturally, right? And companies use a firewall and other security devices to improve the security in their environment, naturally. And sometimes even legal traffic is blocked and or filtered by firewalls. Hence, when a service is not working properly, you should always check all possible firewalls between the endpoints that have problems communicating. So what I'm going to do is I'm going to ping web01 from my current server or host, and then I'm going to add a firewall rule, and then I'm going to check the ping then. Now I want to keep in mind that Win10 uses 0250 as a gateway IP, and web01 is behind the pfSense firewall. So that may mean I may need to add a static route to this host using a pfSense IP as the next hop IP. So let's go ahead and get started. Right. So it's going to ping here. Now, I want to point out also that that the static route that I already added that points to the server 1.1.10 and using the pfSense IP 01 as the next hop with the command. If I sign out, I may have to do it over, but since I did not, then experiment may go a little bit different. But nonetheless, back to this, from the output, it can be seen that there is successful communication to the specified device, directing the ICMP traffic through the router to a different subnet. So let's stop that. So we can abort the ping. I'm actually going to reopen this here. Back exactly where we want to be, right? And pfSense, and I'm going to take a look at the firewall, take a look at the rules. All right. And of course, we're going to be on the WAN by default. I'm going to take a look at the rules that were created for this interface. Let's take a look here. Literally nothing here. Allow IPv4 and version 6 via care shell. All right, so there's a couple different rules. The first one just allow the ping. Now, let me see. Now for this one, if I'm trying to examine the rule, but last time I checked before this taping, I saw that the ICMP protocol is allowed, and using the ping command transmits ICMP traffic to test connectivity to remote devices. So I'm actually going to edit this here. Yep, there it is. All right, and let's see. Let's actually change this to TCP. Let's see that. And I'm going to save it. Okay. Do the byte changes. Perfect. So they're letting us know it's been applied successfully. So I'm gonna put this here. Yes. That guy. Okay, perfect. Apply. Perfect. So we're good to go. Love seeing green. So let's actually bring this down. We're going to pink again. Okay. Now, after altering the firewall to allow only TCP traffic, the communication to the remote device is not possible because the firewall blocks the ICMP traffic, and this causes our command to fail. All right, so I'm actually going to abort this and actually pull this out here. Now, for blocked services, ports, or addresses, services and ports are usually filtered by firewall devices running in your network, but they can also be filtered by the firewall, Windows firewall, and even the antivirus program running on the computer. So even when it's allowed, every port and service in your firewall, for example, pfSense, some services are blocked from the computer itself. So you want to keep that in mind while troubleshooting block services. So what I'm going to do is disable the Windows firewall rule that allows remote desktop connection to this device, then test it out from the last device on Win 10. So now that I'm in, let's go to the firewall. All right, let's take a look at our settings. All right. Thank God for alphabetical order. Okay, we're gonna actually just want to make sure this is the correct one. And it is, so we're going to disable this. So the green tick is not here on the left side anymore. So let's swivel back over here. Okay. Connect. It may still work because of the static route that I added earlier. Nope. So I'm unable to connect to the Web01 server because I have disabled that rule and blocked the remote desktop connection with the Windows firewall rule. So I'm actually going to, okay, here, put out there. I'm going to swivel back over here. I'm going to enable it. We have the green again, and now I'm going to do what I just did. Perfect. And sometimes, as you can see, it works. And sometimes you can also have network time protocol issues. For clock synchronization, I went over this in the prior video. Having the incorrect time on the server can be a problem too, right? BYOD challenges. If you bring in your own device for official, you usually mostly executives do this, really higher ups. Now, in this deployment model, do employ you. They can bring their device of their own choice. It's a trend that makes remote work kind of easy to implement in organizations. Although it's very popular, it has some disadvantages and challenges that need to be taken care of. You can have license feature issues, network performance issues, to say the least. I'm not going to get too much into that, like high CPU on device link congestion, link failure, route flapping, and things of that nature, right? So lastly, what I'm going to cover is remediating miscellaneous network device configuration. So different types of devices can exist in the network, right? And every device has a specific configuration. So different type of issues that can arise on the devices can be similar. And what I'm going to do is create a broadcast storm just to see how it would affect the network. And I can also see some basic DHCP issues that can be present in the DHCP or the dynamic host control protocol configuration, and I'll learn about duplicate IP and MAC addresses, collisions, and similar network outcomes like collisions and collision domain. But what I want to focus now is switching groups and broadcast storms. So let's say a campus area network, campus network rather, might contain multiple switches that are connected to a core switch. Having redundant links between these are very important, right? So link aggregation technology can be used to bundle these links together, providing higher bandwidth. Now, the spanning tree protocol can be used as an alternative, which provide a loop-free environment. Now, if the network doesn't contain a switch that supports spanning tree config, or any of the switches are accidentally disabled, it may cause a switching loop, resulting in network resources becoming inaccessible. So we're going to take a look at some IP configuration here first, if I can spell properly. All right, so we see this here. Okay. Now I can see that I've verified the IP address twice to 0.5, right? Now I'm going to verify connectivity to the DC1 server, the one right above what we're currently using. So let's do this here. It's ping. Looks like we're not getting a response. Now there's two parameters that are used in the Spring. First is the size of the packet right here, and which is specified at 1500 bytes, and the default is usually 32. And then the minus lowercase t option is used to execute the ping command repeatedly until I manually import it. Right. So I'll let that continue. Actually, I'm not even going to stop it, but I'm going to redirect to Kali Linux. Okay, perfect. So let's take a look at our terminal. Okay, that's pretty quick. Well, I love Kali. Right. I'm gonna do this command here. Right. And of course, that's fine. So now we're pinging. Now again, the lowercase l, the minus lowercase l 1000 is an optional parameter for the command I just used. But I wanted the host to tell me, I wanted to tell the host rather to send 1000 packets while waiting for a response. And it usually needs to be run as root, as root, which is why the pseudo parameter is added. So I'm not going to leave it running too long because it can cause network interrupts. So I'll just stop executing it now. 2 to 10. I'm also going to report this one. Oh, there it is. Okay, so looks like while running the broadcast storm from Cali, I lost a few packets to the DCO1 server. Now the number of lost packets, depending on how long you're running it, can vary, of course. But unless I'm going to close this and back to Cali and close this up as well. Right now, want to get into a few different things. But again, for the interest of the video not being outrageously long, when I say a few different things, just duplicate MAC addresses and duplicate IP addresses and how the layer 2 communication works on the MAC address or media access control. Um, on the 48-bit unique identifier burned into a NIC or a network interface card, multicast flooding, asymmetrical routing, and routing loops. Fun stuff, right? But what I'm going to get into is identifying a role dynamic host control protocol server. Now, the DHCP in the network that has the benefit of providing reduced network admin, right? And we must configure the scope with the appropriate DNS and default gateway IP address. So I also have to set my clients to automatically obtain the IP. So fortunately, you can have a rogue DHCP server in your environment, which is a network in your network device in your network that users can connect. For example, a small Wi-Fi router that has DHCP enabled by default, and all the clients connected to the network will receive DNS and default gateway from both legal rogue lesson names. So let's actually go back to set here. There we go. Status, the details. Now I see a few things on the details, like the IP, just subnet, the default, the DNS. They look pretty standard. See, prior to this. Now I'm just going to take a look at our second Ethernet. Okay. Now in this interface, I have an IP address in the range of like 169.254. Looks like, which means that a DHCP server is not available on this network. Usually, even though it says the DHCP is enabled. I'm not sure what that's about, but I'm going to configure a rogue DHCP server on pfSense. So let's do this here. Actually go here. There we go. See. Server on the page. Let's do quick. Let's do That looks pretty okay. Now, this isn't the correct, by the way. This is not the correct IP because it's the rogue DHCP server, by the way. Let's see what else we can do. Okay, and that is also not the correct gateway IP address, but nonetheless, this is a rogue. And you know, rogues are rogues for a reason. Perfect. So the changes have been applied successfully. So now I'm just gonna actually take a look at two of them. Okay, let's go with that. Let's disable this. Okay. Then to enable it. Take a look at the status and the details. Oh, got something a bit different going on here. Now, even though I now have the incorrect DNS and gateway settings, if this were the only interface in the network, I would not have access to the network resources and the connection would not work as it should. So I'm just going to close this out. Now, you can also have DHCP scope exhaustion. Because the DHCP server provides reduced network admin administration. Sometimes if the IP range is not calculated correctly, you could have more clients than available IP addresses in the scope. For example, what I just did, the DHCP scope was created with 6 IP addresses in the scope. Now the 7th client would not get an IP address from the server because we didn't calculate the range correctly. Now 2 clients are connected to the same switch and have the same IP address setting, which could be attained automatically from the DHCP server. And one of them is getting an IP address from a server and the other does not. One of the reasons could be the DHCP scope exhaustion. In this case, simple configuration of the scope would solve this problem, right? But nonetheless, we solved the problem that we were looking to solve for this video. We've reached the end. Just for a brief recap, we went over considerations for troubleshooting network devices, resolving common network connectivity issues, troubleshooting those the network connectivity, and remediating miscellaneous network device configuration. This one was definitely a lot of fun. I genuinely love doing things like these. Outside of, you know, just in general, just love doing it. And this was so much fun. We're going to have even more fun on the next video where we actually go over cloud concepts. It's going to be amazing. It's actually going to be somewhat of a sneak peek for the next a couple of series I have from now when I'm going to get into uh, general cloud things. Then I'm going to get more of a scope into AWS and Azure in particular, as far as different projects and videos on that as well. Hope to see you on the next one for cloud concepts. See you there. Stay curious, stay secure.